All right, so that was translations and reflections. A bit of a look at dilations and reflections. All right, so what have we got? We've got a dilation parallel to the y-axis. All right, so parallel to the y-axis means my graph goes from there, not the best pen. So it goes from there and it shifts upwards relative to the y-axis. Yeah. So that means, so parallel to the y-axis means which coordinate is getting affected here? Okay, my y value gets affected, doesn't it? So the y value gets stretched up. So if we have a look at the notation here, a dilation of A units parallel to the y-axis, or we say from the x-axis, and it's probably the from the x-axis part of it that I prefer, okay? Because that's really just saying to me that the graph is moving up from the x-axis. And if it's moving up from the x, it means my y value gets affected, all right? So we'll keep saying from the x. So from the x-axis, a dilation of A units from the x-axis means my y value gets affected, okay? And so the y value gets multiplied by that factor. A dilation of a factor A from the y-axis, if it's from the y-axis, it means that we're moving this way from the y-axis, and that's my x-coordinate that gets affected. So think that through. If this is the point 1, 0, and I move 2 times from the y-axis, well, it means this point becomes 2, 0. So it's the x-coordinate that gets affected if we stretch away from the y. All right, and again, same sort of thing. The x value gets multiplied by A. Now, this is how it appears in our function notation, but let's have a look and show how we get that. So determine the rule for the image of the graph of y equals 1 on x if it's dilated by a factor of 3 from the y-axis first. So let's go from the y-axis. So same process. Let's start with the point x dashed y dashed. It becomes, okay. Now, if I'm a factor of 3 from the y-axis, it means, from the y-axis means I'm stretching this way, so my x-coordinate gets affected. So the x-coordinate is 3 times bigger. The y value doesn't change. All right, so that's the sum of the transformation. So same process, x dashed is equal to 3x, y dashed is equal to y, but my equation is written as y equals 1 on x. So from there, I need to say that x is equal to x dashed on 3 and y is still equal to y dashed. And I can substitute those values into my equation. So if y is equal to 1 on x, then the y value here is y dashed is equal to 1 over the x value, which is x dashed on 3. So 1 divided by, we can simplify that. So y dashed is equal to 1 times flip and multiply. So y is equal to 3 on x. So once we've got our new equation, we don't necessarily need to keep the dash symbols. They're just there to help us keep track of things whilst we're doing the working out. All right. What about for B, if it's from the x-axis? Same thing, x dashed y dashed is equal to, or if we're stretching it from the x-axis, okay, it means the y value gets affected. So x doesn't change, but y gets multiplied by 3. All right. So that's the only transformations. X dashed is equal to X, Y dashed is equal to 3Y. Rearrange, I'll get X is equal to X dashed, Y is equal to Y dashed on 3. Let's substitute that into my Y equals 1 on X equation. So we've got Y, which is Y dashed on 3, is equal to 1 on X, which is just X dashed. So I can multiply the 3 across now, 3 on X. So in this particular instance, very rarely does it happen, but with my hyperbolas, sometimes my truncus it does, a dilation from the x-axis or from the y-axis happens to give me the same equation. All right, but concentrate on the process. X dash y dash equals, what was the effect that we had on the x and y values? Rearrange, substitute into the rule that we're talking about. Let's have a look at next. Okay, something similar for reflections. So something similar for reflections. A reflection in the y-axis. So reflection in the y-axis means I'm reflecting it around that way. Probably with that pencil's better. Yeah, which means the positive x value here now becomes a negative x value there. So a reflection in the y-axis means my x value gets multiplied by -1. Conversely, a reflection in the x-axis means it flips from up there down to there. So what changes? It goes from the point, 1, 2 to the point 1, -2. So in the y-axis, the x value gets multiplied by -1. All right? So that's exactly the same process now. So it's remembering what the statement, what the description of the transformation tells us in terms of the x and y values. So about the x-axis, well, let's do both of them. So if we reflect about the x-axis, our point x dash y dashed becomes, right, if we reflect about the x-axis, that means the y value gets affected. So we get -y. If I then reflect about the y-axis this way, okay, I then get a -x. So this may not be how the question's intended, but this is the way we'll do it at the moment. You can see the individual ones down here already. So that means x dashed is equal to -x, y dashed is equal to -y. Leads to x equal -x dashed, y equal -y dashed. Substitute that into whichever rule we're talking about. So I do know starting off, y is equal to the square root of x. So y is equal to -y dash, so we get -y dash there, and x is equal to -x dashed, -x dash there. So rearranging, I get y is equal to the negative square root of -x. Yeah, so I can leave the dashes off again because that's just my new equation. So if I wanted to sketch this one in here, it's a reflection one way, and then it's the reflection the other way, isn't it? So that one there is y equals minus square root of -x, all right? Have a go at that process, see how you go.